welcome back to my channel. Today we're going to have a look at metal reactions. Different metals react differently with oxygen, water and acid. When they do this, they produce different products. If you react a metal with oxygen, this is the basic word equation. Metal plus oxygen to give metal oxide. If a metal reacts with water, this is the word equation. Metal plus water to give metal hydroxide plus hydrogen. And finally, if a metal reacts with acid, you'll produce a salt and hydrogen. By reacting metals with oxygen, water and acid, you can place them into an order that we call the reactivity series. Very reactive metals will react very quickly with oxygen, water and acid. Here are some examples of very reactive metals. Potassium. If you put potassium into cold water, then it will burn with a lilac flame. Sodium. If you add sodium to cold water, it will fizz around on the surface of the water very quickly, as will lithium. If you add calcium to cold water, it will sink to the bottom of the water, but it will very quickly give off gas. Moderately reactive metals will react with acid and with oxygen, but perhaps not with water. Examples of moderate reactive metals would be something like magnesium. Magnesium would burn in oxygen to give a very bright white flame. Another moderately reactive metal would be iron. This rusts when in contact with water and oxygen. Unreactive metals might react slowly with oxygen or have no reaction at all. An unreactive metal would be something like copper. This is used for water pipes, or gold, which is used for jewellery. If we put these into order, we get a reactivity series. We can, on the reactivity series, show where things will react. At this point here, these metals react with water. If we put in a point here, everything above here would react with acid. The metals which react violently with water we would not want to put into acid, as the reaction would be too violent. And things above this line would react with oxygen. The metals at the top are the most reactive, and the metals at the bottom are the least reactive. Put the metals in the table in the order of reactivity from most to least. So here we need to look at the different reactions that we have. So W reacts quickly with oxygen, very quickly with water, and violently with acid. X does not react with anything. Y reacts quickly with all things, and Z has a mixture of reactions. Let's look at the two extremes. Our most reactive seems to be W, as this reacts violently with acid, and our least reactive seems to be X. We then need to look at the two in between. We have Y and we have Z. Y reacts more quickly than Z, so we must have Y after W, and then Z afterwards. Metals are found in nature in rocks that we call ores. Ores often contain things like metal oxides or metal sulfides. The metals can be extracted from the ores in different ways depending on the reactivity. When we extract the metal, we need to break the bonds between the metal and the oxygen. This can take a lot of energy depending on how reactive the metal is. If we go back to our reactivity series, where we have the most reactive metals at the top and least reactive at the bottom. If we put a line in here, gold can be extracted using heat alone. So if you found an ore that contained gold, you would just heat it up and the gold would come out. Heat would be enough to break the bonds between the gold and any element that it happens to have reacted with. This section in the middle needs a little bit more help. So here we would heat with carbon or carbon monoxide. When we do this, the carbon forms bonds with the oxygen or the sulfur. These bonds are stronger than the metal makes with the oxygen or the sulfur, and therefore are preferable. This means that the oxygen and the sulfur are pulled off of the metal and leave the metal behind. For the most reactive metals, this is not enough. For the most reactive metals, we need to use something called electrolysis. In this case, we melt down the ore until it's a liquid, and then we put in carbon rods and we pass electricity through the molten liquid. This then allows you to separate the metal ions and the non-metal ions. The metal ions will then be attracted to the negative electrode and you'll produce the metal by itself. This takes a lot of energy. Pause the video now and identify a suitable method for extracting each metal from its ore based on its reactivity. W was our most reactive metal. The best extraction method for this would likely be electrolysis. X didn't seem to react with anything, so you could probably just heat up an ore with X and be able to extract it. Y had fast reactions, so you would either need to heat with carbon or electrolysis. We don't really have enough information here to say which. And then Z had some slow reactions. Heating with carbon is probably the best here. Thank you for watching my video. I hope that you found it helpful. Please remember to subscribe and ring the bell to be notified of new videos. You can also follow me on X at Miss Adams Chem, Instagram Miss Adams Chemistry, and TikTok Miss Adams Chem for updates on new videos, flashcards and short videos throughout the year. Bye for now.